Hello everyone, welcome again. And in this video, we will continue our learning on reservoir simulation. And in this video, I will introduce you with a reservoir modeling and simulation software, which is quite widely used, all right, in oil industries. And the software is tNavigator from Rockflow Dynamics, all right? This software is very good. So let's learn together in this video. So we have several tools or features here. As you can see, we have Geology Designer, Static Geology Modeling. Okay, so if we want to construct static geological model, we can use this one. All right, and then this one, Model Designer, if we want to create dynamic model. So you have static model, and you can also have dynamic model. Okay, for petroleum engineering, we mainly involve in model designer or in dynamic model creation. All right. So if we want to generate a dynamic model, we will use this tool, model designer. And PVT designer, if we want to create PVT model, all right, this is very important. The fluid properties will be modeled in this designer. VFP designer, this is to construct vertical lift performance to correlate between the bottom hole with the surface. All right. You remember nodal analysis? We have IPR, inflow performance relationship, and we also have VLP, vertical lift performance. All right. And here in this designer, in this tool, we construct VFP. All right. And then here, network designer. If we want to model the network, the production facility, we construct the facility using this network designer. License, this is to manage the license. And simulation, this is very, very, very important. Black oil simulation, compositional thermal simulator. If we want to perform, for example, forecasting, all right, uncertainty analysis, we can do that in simulation. Simulation results to visualize the results, okay? But we can also visualize the results using this simulation. This one, AHM, which is assisted history matching and uncertainty analysis. Oh, I'm sorry. For uncertainty analysis, we will use this one. And others, batch jobs, remote GUI, graphical user interface, and the manuals. Okay, so in this video, we will construct a dynamic model. Hopefully we can do history matching at the end. So, okay, let's do that. First, we go to this one and I will create a new project, create new. Okay. And I will construct or I will create a folder. Okay. Okay, this is the folder. Open it. I will save the project file here. So I will call it project underscore simulation. That's the name of our project file. And the type is model designer project SNP. Okay, click save. And we will wait until the tNavigator is ready. All right, here we go. Wait for a while. Okay. Now this is our window. There we have several messages. Here the window. As you can see, in this bar we have cases. If we want to create the cases, later on I will talk about this one. Geometry objects. So everything, the main data, the static data will be created here and will be also shown here. As you can see, wells, markers, well attributes, logs, horizons. And what we will do is mainly here in 3D grids, three-dimensional grids. Still empty. Okay, later on we will save or we will have our data here in this section, three-dimensional grids. Well, structure tables still empty. Everything is still empty. And here we will have our fluid properties, the PVT, and also the rock compressibility, still empty, all right? Initial, PVT, relative permeability, all of these things are important, okay? So you learn reservoir simulation, you learn reservoir engineering, you know relative permeability will be used here. The PVT, and this is for the equilibration, the initial condition before the production, and here the rock compressibility. Wells data, okay, the perforation will be here, okay, the perforation history, the production history will be stored in this section. And if you want to do data analysis, later on we can do data analysis and the graphs. To plot the production, the history matching results can be plotted in graphs. All right, go back to geometry objects. We can have 2D map, two-dimensional map, three-dimensional model, the seismic, cross-section, well stable to show the trajectory of each well section, okay, to show several information about the well, histogram, VPC, cross-plot, geosteering, table, but most of the time we will only use 2D map or 3D model. And also this is very important, the settings. We can do management of each feature. Each item can be managed here in settings, like grid settings, the setting for wells, and others. Yeah, you will understand better if we have our data shown in the window. And also several tools like this one, if you want to create cross-section, okay, ruler to know the distance between one point with another point. For example, between two wells, we can measure the distance using ruler. This one, statistics and information. If you want to do, or if you want to know the statistics, the average, the minimum, the maximum, edit curves, rotation point, show brush configuration, to brush. Later on, hopefully we can cover several of these items. Okay, and above we have document, view, files, queue, project manager, and print. Let's open the document. We can also check the settings. Okay. And then the templates. All right. So now we will import the data. Here we have two options. Import data from rescue file. So we will use the rescue file created for example, from Petrel, static model from Petrel. We use that model and yeah, we modify something or we insert the fluid data, the dynamic data into that model. Okay, we will use this one rescue file, but we can also do importing from existing model. So for example, if we have created simulation, forecasting and others, and we have the file, we can use that file, we can open that file, and we can do modifications in that model here. So we can either have this one existing model or rescue. If we use rescue file, it means that it's like we start from zero. Okay, we give data, let's say from zero, but existing model, it means from the name itself, existing, it means the model is already there. It's already exist, okay, with all the data that is important. But for our learning, it is better for us to start here, import data from rescue file. Okay, that's what I will do. Import data from rescue file. Okay, and I will get my rescue file. Here, this is the type of the file, .bin cas_rescue from Petrel usually. Open. And yeah, we need to make sure the units, XY coordinate in units, XY units, I mean, in metric, okay, metric unit. And for the length measure, also metric. Okay, this is the name grid or main grid. This is the rescue file name. This is the grid coordinates, everything in metric unit, okay, or in meter, for example. And here we have grid and properties. Load grid and properties. Yes, we will load the grid and properties from the rescue file. And from the rescue file, we have these items or these parameters. FBID, all right, it's just an identification. Perm_X, permeability in X direction. So we have that grid from rescue. Poro, it's actually porosity. NTG is net to gross. Okay, we have three static parameters: perm_X, porosity, and net to gross. And this is the quantity and the system, and also well bores. So here is the list of the available well in the rescue model. So, and this is the name. So we have 33 wells. Okay, we will load the well bores, append to existing, and add point with 0 MD. Okay, we will leave it as per default. Okay, and horizons, we have two horizons, the bottom and the top. Okay, so click OK, and we will wait. All right, so this is our model. Okay, interesting. All right, let's start. So this is the two-dimensional map showing this one, horizons already ticked and zone ID. Okay, if I change from zone ID, now I'm showing the zone ID. If I change it to FBID, it's like this one. Okay, the boundary, you can see there is no boundary. Now the boundary. And perm_X, it's like nothing changed, right? If we go from perm_X, poro, NTG, nothing changes here. It's because we are still opening this one, the horizons. So I will untick this one. So now I will only show you the NTG. This is the distribution of the net to gross across the reservoir. And this is for the porosity. And this is for the permeability in X direction. Okay. All right. FBID, it's just an ID identification. Everything is the same. All right. And this is 2D map. And you also have this scale, right? Okay. Now if we change to 3D map, it's still like this, because you see, if I change to 3D, I still haven't selected any of this parameter. Let's plot perm X. It's like this: permeability in X direction, the porosity, the NTG. Okay, that's basic. And also, if you want to change the direction, like what I do here, you can just press left key on your mouse, hold, and change it like this. If you want to move all of them, right click on your mouse, and yeah, you can move. I'm still holding on the right key. If I want to zoom in and zoom out, just scroll. And if I want to make it back to the original view, I can press right key and left key at the same time, like this one. And you can see it's too thin. Okay, I want to adjust the size of what I see. I can right click without holding it, right click, adjust size, like this one. This is better. All right, and more realistic. This is 2D, this is 3D. And here we are going to the settings, still in general, 2D, grid settings. Now you can see we have palette, show palette. Now you can see I have the palette showing the scale of the current parameter. Current parameter is perm X. So the scale is from 0 millidarcy to 3000 millidarcies. 0 will be blue, 3000 will be red. This is the palette, okay? And I want to show the palette also for 3D. Open the grid, main grid, show palette here. Okay, I'm showing you the NTG. This is for the perm X. Okay, so far so good. Beautiful, right? But it's still very, very, very early if we want to show or if we want to close it off. Okay, it's still too early. And usually we want to see the permeability and also porosity at the same time. So I will create another 3D window. So I can do that by clicking this one. I want to add another window, 3D. Okay, and now I will select the porosity, adjust size. Okay, like this one. I want to put it here. So this is for permeability. This is for porosity. Okay, and then I want to drag it, or sorry, I want to see them simultaneously. So I can do that like this one. I will drag the 3D one, the porosity window here. Okay, so I have two windows. Okay, like this one. This is porosity and this is the permeability. I can move the permeability and I can move the porosity. But I want to see it simultaneously moving, okay? So I can right click or wait for a while. So I can do that by going to the general, synchronize camera. Okay. And also here, synchronize camera. So now I can see they are moving together. I can see the perm X and porosity at the same time. And here we have the trajectory of each well. You can see we have vertical wells and the name of the well is there. Okay. If you are not very comfortable, you can make the trajectory looks shorter and the name will be closer to the reservoir. I can do that by going to the wells, here wells. Okay, and then cut trajectory by depth. Okay. Yeah, I will do this like this one. And also this one, wells, cut trajectories by depth. Okay. All right, so far so good. Okay. And then you can maximize, you can zoom in, you can see. Let's say, yeah, you already understand that. Now I want to have only one window. I will right click and close this one. You can maximize. You can select this one and you can see the grid. Go to main grid, show the grid lines here, grid lines. Yeah, you can see the grid. Okay. As what we learned in reservoir simulation lecture, we must have grids in our model because the grid will be the unit of our calculation. The computation will be in each grid. Okay, we can also show it transparent like this one. And show framework only the framework. Okay. All right. And also for 2D map, here we are showing the roof view. It means that we are looking it from the top, from above. We can also change it to each layer. So we are now in layer 1, layer 2, layer 3, layer 4, layer 6, 7. Okay, because each layer is different. Okay, if we want to if we want to sum up all the parameters in all the intervals, sum. Okay, so it means that for permeability, if we sum all the permeability in each layer, this area will have the highest permeability, the red one. And for minimum, okay, so the minimum permeability will be blue color, and all layer has for at least one zero permeability, one blue permeability. And max, okay, so it means that very high permeability is only located here in red area. And maybe you can correlate that with geological explanation, why we only have high permeability here and not there. Okay, you need to ask your geologist friends and let them explain that. And also the average, standard deviation, roof from the top again, bottom. All right, from roof again. Okay, and for layer, we are looking it from IJ view, which means XY view. We can also change it to IK. Okay, IK. It's like this. All right, you can imagine it. This is IK, IK or XZ. And JK, JK or YZ. All right. Okay, go back to IJ, go back to roof. All right. So now we still only have perm X, permeability in X direction, and porosity, and also net to gross. We at least need two permeability directions, which is permeability in Y direction and permeability in Z direction. Okay. Now we only have permeability in X direction. So I can create those parameters by doing this. I will call it first, right click, object settings. I will rename it as perm X, all capital. And this one, object settings, poro, all capital. And also NTG, net to gross. Okay. Now I will duplicate this one, perm X, and I will call it perm Y, permeability in Y direction. Click OK. I will move it there. So I have perm X and perm Y. Now we are in perm Y, permeability in Y direction. I can use this one, the hammer, to have my calculation. I will open the calculator, arithmetics. So I will create a code for perm Y. So the code is quite simple. Perm Y is actually the same with perm X. So I will just type in like this one, perm X, okay? Or I can delete and select the parameter here. Double click there. So if I click apply, it means the permeability in Y direction is actually the same with permeability in X direction. Okay, this is the calculation or the code. I will take permeability in X direction as permeability in Y direction. Okay, click apply, done. Arithmetics done. Now I will create permeability in Z direction. The same, I will duplicate and I will create permeability in Z direction. Click OK. I will locate it there. I will open the calculation. I can do that by opening the hammer or right click, show calculations. All right. Now we need to give comment for perm Z. Usually the permeability in Z direction or permeability in vertical direction is smaller than the permeability in horizontal direction or in X and Y direction. So yeah, as a best practice or maybe as a rule of thumb, if we don't know the permeability in Z or in vertical direction, we can do like permeability in X or in horizontal direction multiplied by a fraction. Okay, and in this case, I will use 0,1 or 10%. It means that the permeability in vertical direction is only 10% of the permeability in horizontal direction. Okay, so I can click apply. All right. If you change from perm X, the looks will be the same. Because in reality, the value for permeability in Y direction is taken from permeability in X direction. And the palette is also the same, right? But if we change, or if you move to permeability in Z direction, the looks is the same, but the scale is now reduced 10% from the permeability in X direction. So the maximum value for permeability in X direction is 3000 millidarcy, but in Z direction is 10% from 3000, which is 300. Okay, so far so good. I hope it's clear. I can also drag this one by clicking the left button and move it there. Okay, so now I have 5 main parameters, 5 main properties for static model: permeability in X direction, permeability in Y direction, permeability in Z direction, porosity, and net to gross. These 5 parameters are the basic, the minimum requirement for us to do simulation. Okay, if we don't have one of them, we need to provide with the grid consisting of this parameter. All right, of course, you can also have grid for other parameters like saturation or also capillary pressure maybe, and many other parameters. You can have that. Static Young's modulus, Poisson ratio, all right? All parameters, we can have grid of them. But the main or the basic, the minimum requirement that we need is these 5 parameters. Okay, so far so good. We can save. All right. So yeah, that's the basic. And now we can go to fluid properties. Okay, fluid properties. Okay, this is for relative permeability. We have the data of it, the permeability or the relative permeability for water oil versus water saturation. Okay, relative permeability of water will be or is shown in blue curves. Permeability of oil, red curve, and the green line is capillary pressure. And gas oil versus gas saturation. Okay, we are still using the default value, but most of the time we have to modify these numbers as per our laboratory data. Okay, but we will keep it for now. Okay, and for the PVT black oil, like this one, we have variant 1, the model variant 1, and currently we only have water. We have 2 properties: formation volume factor and viscosity. Okay, we need oil properties and gas properties. Okay, we can do that by clicking this button, launch PVT Designer. Okay, now we will go to PVT Designer to design the PVT model, especially for oil and for gas. Click. All right. All right. You can click close. The name is variant 1, or we can also rename to PVT. All right. This is for water, and we need to provide for oil. We click this one. We click oil. And for now, for simplicity, we will just use these default numbers. So the minimum, the maximum, the table type, the correlation, we will use, standing, or maybe Vasquez Bags, Bags Robinson, right? That's why we need to learn, or we need to study the PVT analysis, the keto. But for simplicity, I will use standing instead for all the parameters. And using these correlation parameters, the temperature, the oil specific gravity, gas specific gravity, bubble point pressure, isothermal compressibility, and also the GOR, all right, gas solubility, calibration coefficient. If you want to do viscosity versus temperature, you can select this one, and we will use this table. All right, if you want to simulate or model viscosity as a function of temperature. All right, and as you can see, by increasing the temperature, the viscosity will be lower. Okay, so this is the typical, or this is the default numbers. In reality, you have to use your PVT laboratory data, but for simplicity, we can click OK. So now we have oil model that will be used in our simulation, in our modeling. All right. Okay. Yeah, you can see the plot, the gas solubility, RS, or gas oil ratio, and also the formation volume factor, the blue line, viscosity, the red line, compressibility. Okay. And this is the plot and the table. This is viscosity versus temperature table. All right, so far so good. Now we need to construct the gas. Open again, gas. Again, I will use the default numbers. You can see for viscosity, you can use Lee et al. Oh, only Lee et al. Is available. And for gas formation volume factor, only standing. Okay, so the temperature 100, specific gas ratio, specific gravity of the gas 1, Z factor 0.9. Click OK. And this is the plot. We have formation volume factor, viscosity, and compressibility, the gas, the plot, and the table. So far, so good. The data will be automatically stored in the model designer. So from here, we can close. All right. Okay, you can see we have oil, we have gas, and we have water. All right. So PVT, okay. Now equilibration data specification. We have equilibration data specification. For equilibration, this is very important for initialization. So by providing the data here, so the software will calculate or will predict the equilibrium condition before the reservoir is drilled, before the reservoir is, the fluid from the reservoir is produced, before anything, right? In virgin condition, the equilibration. And also data for RS versus depth and RV versus depth. We don't have the data here, but for simplicity, tNavigator can help us. Okay, right click, create default by grid. All right, so the tNavigator will calculate it for us. I will remove this one, and I will rename it. Okay, so by doing this one, create default by grid, I have this one, the datum depth, the datum pressure, the pressure at the datum level. Usually, rule of thumb is 10% of the depth. Okay, the datum depth is actually the depth that we select as a base for our model. Okay, maybe we can also call it the zero depth, the standard depth. Okay, the very basic thing is like the center of the reservoir, the center, the middle point of the reservoir. Okay, that's we call datum depth. And this is the water oil contact. Rule of thumb in tNavigator is datum depth plus 100 meter. This is WOC capillary pressure, we need to provide that actually, but we can skip it for now. And the gas oil contact, it is datum depth minus 100 meter in tNavigator. And also initialize live black oil by RSVD per PVT 1, and we can use star for this cell. Okay. And also this one also populated automatically if we right click create default by grid. So you can see create default by grid. It means that we will create default numbers, okay, in this model, in this feature by grid. It means that the tNavigator will use the data from the grid, from the main grid, and populate the data to fill the data into this one, into this table, and also RV versus depth. Okay, so far so good. So done for equilibration and data specification. All right, now we need to fill raw compressibility. Okay, raw compressibility. Again, right click, create default by grid if we don't have the data, but in reality, we must provide the actual data from laboratory to and fill the data here. But I don't have the data for this example, so I will create default by grid. I will use the grid, which is actually the main grid. The name is main grid, main underscore grid. Click OK. All right. So the pressure is 35.5 and the compressibility at that pressure is 5 times 10 to the power of minus 5. I want only one. So I will right click here, remove, and I will rename it as raw compressibility. All right, so far so good. Make sure we save it. Okay. So now we are done with this one. Okay. And for fluid properties also, oil, gas, and water. For relative permeability, PVT, equilibration data specification, raw compressibility. Now wells data. This is also very, very important. We need to provide production history. We need to provide perforation history to our model designer. And if we complete this one, we are almost ready to perform simulation. Okay, so here we have well production tables. We will store our production data here in this well production table. And for well structure table, we will store the data regarding the perforation history. Okay, perforation history. And we can skip it because we don't want to group the wells. And we are still in tables. We need to also provide the strategies, the production strategy, development strategy, when to perforate, when to produce, okay? The limit of the production will be controlled, will be governed, and will be managed with the strategies. And the schedule, later on, it will show all the history, all the schedule. And if we have VFP, all right, the vertical fluid performance, okay, or vertical flow performance, we can import the VFP from the table from VFP Designer, okay, or from any other software. We can import and attach the VFP in this model, okay? But we will skip it for now because using VFP, it will make the calculation longer, okay, heavier. So we will only concentrate on the tables, strategies, and schedule, okay? It's okay if you don't understand for now, but Later on, if we have stored the data, you will understand better. Okay, so for now, we are in well history, well production tables in well history. Okay. Okay, so to populate this table with numbers, with data, we can do that manually. For example, we can open the drop-down menu and we select, for example, well one at 1st January 2010, produce with oil flow rate of 100, all right, standard meter cubic in per day, and also water rate, the gas rate, the liquid rate. This is the reservoir liquid rate, gas injection rate, and others. And the table is quite long. Okay, but we have 33 data, 33 wells, so it will be very troublesome for us if we want to do that manually. So I will import the pre-existing table for production history. I have prepared that along with the rescue file. So I will click this one, import table. We can import history one table, import history group by wells if we have the well groups, import history in Mores format, and import history field history file format. Okay, we will use one table. Right, we have import wells history window, user for use for identification, the name, well production table name will be well history, and add rows, and we will take the data. And the data is actually this one, gas history. The production history data is written in this text document file. Okay, click open, and tNavigator will read the table. And in that document file, we have several columns. First column, well, date, oil rate, water injection rate. This is, and this one, and also skip line. Make sure all the units are okay. So now we are currently using these units, liquid rate, gas rate, everything in metric. Okay, so far so good, it's okay. Click history. And we will take this one as well. And I want to skip this one, okay? I want to skip this one. And I can do that with, yeah, or this one first, skip line. Yeah, and also the date format is, yeah, dd.mm as month and year in 4 numbers, okay? All right, let me check. We can click OK. All right, now we have this one, the table. Or maybe we need to do some modification because actually this one is actually bottom hole pressure. Okay, so let me check. Yeah, we need to delete this one. Okay, and then well production table, right click, create. Okay, well production table. Click OK. And this one will be well history. Okay. We are now in the well history. Again, import one table. Okay. We have that already. Now this one is actually bottom hole pressure. Okay, so we have well, date, oil rate, water injection rate, and bottom hole pressure. And the others will be skipped. That's why we use skip line. And also this one skip lines. So it means this first line is skipped. That's why you see gray colors like this one. Okay. If we change it to 2 or 0 to 2, or unfortunately, I click enter too early, create, well, history, okay, and then import in one table, this one. This is bottom hole pressure. You see, if I click or if I write 2, you see the second line, the second row will be gray. Okay. If I use 3 lines will be gray, will be inactive. Okay. First line, second line, third line. I just want to skip this one. That's why skip lines only one. Okay. You see, everything is inactive. It will not be stored in this main table. That's the meaning of it. Okay, so click OK. All right, this is the table that we want. We have oil rate, water injection rate, everything in 0, and also bottom hole, flowing pressure. All right, now I'm not comfortable with many columns here empty. So I can click this one, anything on the top, right click, select columns, select non-empty columns. So I will only select all the non-empty columns. This one. So I will uncheck automatically all the empty columns. Click OK. All right. So you can see we have well, first column, second column date, oil flow rate, water flow rate, water injection rate, 0. Okay, no water injection well, and bottom hole flowing pressure in 30 bars absolute. Okay, so far so good. Now the well structure, the perforation history. You can do that manually. Again, the well, the date, the event. The event can be perforation like this, or squeeze, or plug the interval, or stimulation, fracturing, well testing, barefoot, install tubing in the casing. We do something with the casing and the packer. Okay. The top, in this case, for perforation, top perforation, bottom perforation, the depth, the skin multiplier, inside diameter, outside diameter of the casing or of the hole, the roughness of the tubing, okay, outside roughness of the tubing, porosity system, and comment. Okay, again, we will import one table, add rows, and the data that will be used is this one, CASPERF. Okay, this is basically the example from tNavigator, example sample from tNavigator. That's what we learned today. That's what we use today. This is very, very important for us to learn this software, which is very, very interesting. Okay. And the delimiter, all spaces. Okay. Skip line, again, the first line will be skipped. The first column is well. The second column is date. Make sure the format of the date is the same. The event is perforation, top perforation, 300 meters, the bottom perforation 365 meters, and this one is actually, as you can see from the gray color here, diameter. So we change from radius to diameter. Okay, and you can see here we have skin still active, multiplier still active, but actually the columns are empty. So I will put the skip line comment here. So I will skip the rest. Okay, click OK. Now I have the perforation event, the well structure, and the event that we have only perforation for this basic example. Okay, so we have well, the date, the event, perforation, the top and bottom perforation, okay, and inside diameter of our well. Again, touch this one, right click, select columns, select non-empty columns, click OK. All right, so far so good. All right, you can see we have perforation, we have production. We check the schedule, not yet. Okay, later on we will have the operation parameters written in table in this window. Okay, this one is strategy, so we will define the development strategy. We open this tree first, global rules. Okay, so we have several rules that will govern this simulation, okay, this modeling. All right, you can understand as I talk about this. Okay, the first rule, input well trajectories. Okay, so yes, that's the first rule, input well trajectories for all wells. Okay, and then input VFP tables. Okay, but we don't have the VFP right now for this example. And input well structure. All right, input well structure, and we have the well structure file, which is this one, well structure. What is this well structure? This well structure table is taken from this well structure. Okay, so we have the table, the name is well structure, and that will be used here as one component of our rule. Okay, all right, let's check, not yet. Okay, now in addition to these global rules, I want to add some other rules like production and production history. So I can do that by clicking this one, add new strategy, or add new strategy. If you want to create another development strategy that you want to exercise, but not. All right. And okay. All right. Okay, but before doing that, before adding another rule, we want to show, or we want to create the time steps for the calculation. Okay, the time steps, that is very important. And here we have, you can see we have the time. For example, we have 1st January 2014, and then we have this one. Okay, and maybe we can check again the format, one table. Okay, the format is like this one. Okay, DD YY. Okay, so we have 6 dates: 1st, 2nd, 3rd, 4th, 5th, 5th, and 6th. So we should have 6 time steps. Okay, that's why in strategies, we will use this one, open time steps editor, or we can also use, all right, this icon, open time steps editor. Okay, and we need to select the development strategy, but we only have development strategy one development strategy. So select this one, and we can add time steps like using this one, add time steps. If we want to add single step, okay, this add time steps is used if you want to add the step one by one. That's why the step length is single step, 1 year, 6 months, like that. Okay, click cancel. I will not use that. But what we will do is this one, add time steps from tables, because we already have the table. That's why we will use that table to make the time steps. If you have RFT log, you can also put that here. Okay, I will use this one. Well production table. I have well history to govern the time steps. So I will use well history to list the time step. So you can see we have 6 time steps. And now we have these 2 flags. The first flag for the beginning, and the second flag is for the end of the time step. And also maybe we have another time that we want to locate in our time steps. Let's check well-structured tables. Well-structured. Okay, in well-structured, we also only have 6 dates. That's why we only have 6 steps. Okay, maybe different. Production history, you have several times, but for perforation, another time. Yeah, the list will grow as per the available data. But we only have 6 dates or 6 time steps. That's why we only have these dates. Close. F1 and 6, but where are the 2, 3, 4, 5? We can show them by right click, open time steps editor. Oh, sorry, this one. Uncheck the hide steps without rules. Okay, so now I have this one, the first flag for the start, the beginning of all the history, and this one, the end or the end of the if available history. All right, so now we will add rule here. Right click, add new rule. All right, we can have many rules, as you can see. For well settings, we have well specification parameters, well connection. For control, we have well status, efficiency factor, and historical well controls, forecast well controls, and others, many rules. Rules are actually the thing that we desire, or the thing that we target, the thing that we want, or the thing that already happened, and we want to use that as a rule, as constraint in our model. Okay, so if in reality the production rate is 100, then we want 100 to happen, to occur in this model also. That's why we say this is the rule, that this well is produced with flow rate at 100, because that's what happened, that's the fact, and I will use that fact as rule. Okay, but we can also have another rule, for example, production. So I will forecast the production, but the maximum flow rate is, for example, 1000. So the model will do the forecasting, but the maximum flow rate will be set as per the rule, and the rule is maximum 1000. And the rule can also be minimum bottom hole flowing pressure or maximum bottom hole flowing pressure. maximum flow rate, minimum flow rate, economical flow rate, many things that we can set as rule or as constraint, or we can also as control. Okay. In Embal software, for example, we call it constraint instead of rules. Here we call it rules. And now because we already have historical production history, I will use that history as the rule. Okay, so I will click this one, create historical well controls by table. Click OK. All right. So this will be the rule for our simulation, for our model. Create historical well controls by table for all wells, but we can select each one. Maybe we just want to use a particular well for the rule as the governing rule. Okay, and also we can do filtering. If we have a group of wells, we can create well filter. But in this case, the best practice is all wells. You have available data for all wells, then you can use that as the rule. And the production table that will be used is well history. The table is here. The name is well history. And wells type detect by rate. So if the rate is positive, it will be producer. If the rate is negative, it will be injector. Okay. And now we have for each type of well, producers, water injectors or gas injectors. For producers, well status open. Okay. And we will control with liquid rate. Okay. The control mode will be based on liquid rate. So the model will try to match the liquid rate first. Okay. So the model again, the model will try to match the liquid rate because the liquid rate is now the rule. Okay. The existing available production data based on liquid rate, the liquid rate from history will be used as the control, as the rule. Okay, so the model tNavigator will try to perfectly match the liquid rate and will calculate the oil rate, water rate, and others. Okay, and yeah, by calculating the bottom hole pressure. Okay, all right, and also water injectors, control mode, injection rate. All right, and will be based on bottom hole pressure. We will use the historical value of the bottom hole pressure, but we don't have actually injection well. So yeah, it's okay. We can leave it as it is for water injectors and gas injectors. Okay, so far so good. You can also add another rule for each time step. For example, you want to set again the historical production as the control, as the rule. But if we put the rule here, it means that for the following steps, the rule will be the same. So it will be applicable also for this time rule, this time steps, I mean, for this time step, this time step. Okay. So it will be applicable for all time steps following it. Okay. Now we go to schedule. Everything will be automatically shown here. All the rules, all the information that we provide will be shown in well definition. This is for well production. This is for multi-segment wells. No multi-segment. We don't set anything for economic limit. So it will be empty. Group operation, no. Network operation, no. Other operation, no. All operations will summarize everything. We'll list down all the rules or operation parameters. And you can see this one, for example, or go to definition, well specs, well definition, the well name, the group, and the code will be like this. Okay, that's for well specification. And well track, this is the code for trajectory. And this is actually the trajectory, but written in this format. And also perforation, the code will be com.md. And yeah, this is the code. So you need to be familiar with this code system. Like this one, this should be well named. This is the upper measured depth of the perforation. This is the lower measured depth for the perforation. MD is the type of entered interval. Open or shut flag of connection. This is open. This is saturation table. It is skipped. Transmissibility skip. This one is wellbore diameter. Order of connection and well production. The code is this one, well control history, because it will be based on history. Operating target, okay, well control, okay, will be based on the pressure. Again, well history, and so on and so forth. Okay, you see the calculation create schedule is complete. So now we are ready to do the simulation, to do the history matching, to do the simulation, but we need to set everything in cases management. Okay, so we go to this tab, case. So now we will list down all the available information that will be used by tNavigator to do the simulation. Okay, so we will discuss the case management. All right.